Let's take a look at another example of the empirical rule. This time let's look at it through the perspective of z-scores. Remember, every data we collect has a z-score, right? It measures how far above or below average you are. And so we can analyze data through its z-scores. And so looking at this first example here, example 2 from our notes, what's the probability that a z-score, right, when you have the data that's normally distributed, right? And so if it's normally distributed, the z-scores will be distributed this way also, right? Mean of 0 in the middle, z-score of 1, 2, and 3, right? Which means that's how many standard deviations you are away from the mean, -1, -2, -3. So what's the probability that a z-score from a data is between -1 and +1? And so what you need to visualize is the normal curve. Here's a small one that you should memorize and draw by hand and be able to recreate that, 68, 95, 99.7. And so here is another perspective here. I'm going to zoom in a little bit more. Here's that curve, and kind of knowing, again, here's your z-score of 0, right? These are z-scores. There's your z-score of 1, 2, 3. And then if you're below average, -1, -2, and -3. So basically what we're saying is what percent of the data is between -1 and +1 z-scores? And we know that answer is 68%. But you would want to draw that out and then kind of represent, there is your 68% from here to here. There's your z-score. And so I want to make sure you recognize that. Next question is looking at z-scores between 1 and 2. And so now we're looking at the values between 1 and 2. Important, I think, also when you draw these z-scores and understanding the normal distribution and proportions and probabilities is kind of recognizing what percents are, if we have these values, like this represents half of the data, 100%, and then from here back is half. From -1 back, there's 16%. Remember, because 16 plus 16 is 32, and plus 60 is the leftover part. So if there's 95, there's going to be 2.5 on this side. If there goes to 99.7, there's a 0.3, right? And so you have these values on this side, 0.15. You have this value on this side, right? So from here on is 2.5%. You may want to, again, pause and take a look at that. And so from 1 to 2 right here, that answer is going to be 13.5%, right? From 1 to 2. So I'm looking at what percent of the population is between these values right there. And you get 13.5%. Now, again, where are those numbers coming from? Think about that real quick. Where am I getting those numbers? Okay, it's coming from 16%. Okay, 16%, because that's from here to here, 16. From here to here is 2.5%. And then you could go ahead and subtract those two, and you get your 13.5% right there. So that's where that comes from. And then the rest of them follow suit. That way you're going to want to take a look. Greater than 2, what percent is greater than 2? There's my 2 here. And then I'm looking for this population here, and there's your 2.5% from this line greater. -1, here's your -1. So I'm here. So 16% are below me. And so you can take a look at the rest of those as try to figure out where those come from as we go through this. Some other notes, again, so you want to do that. And it's important that you draw them out the way we have here and then kind of look at the picture. So that might take you a little bit to do, but this is doing it by hand. We're going to end up doing it by computer or use some rules. You also have some guidance here, but I like you to think it out. So try to think through those pictures, and there's some guidance here about how to do that. We'll do these problems here. But looking at technology, which we end up using, which you're going to use to check answers. Technology is going to give us exact answers. What we have here are some rules that we would use. We're going to use StatCrunch. I'll show you that. We don't use the TI calculators, and then there are tables you can look, especially if you look up online and do some. But we're going to use technology to do that.